In this video, we will see how to use the half-life formula to find the initial mass of a decaying substance and then use that initial mass with the half-life formula to find how much of that decaying substance remains after a certain number of weeks. So here it says the half-life of palladium-100 is 4 days. After 12 days, a sample of palladium-100 has been reduced to a mass of 5 milligrams. What was the initial mass in milligrams of the sample? What is the mass 5 weeks after the start? So to find the initial mass, we'll use the half-life formula, which is the amount of mass remaining equals the initial mass times half to the h power, where h stands for the half-life of the decaying substance. So it's how long it takes for half of the substance to decay. We already know from the problem that the amount of mass remaining is 5 milligrams. So that's our amount of mass remaining. And h, our half-life, would be 12 days that it takes to reduce the mass to 5 milligrams divided by the half-life number of 4 days. To find how many half-lives, so how many times that substance is decays to a half. So like after 4 days it would be half of the 5 milligrams, and after another 4 days it would be half of that, and after another 4 days it would be half of that. So if we divide 12 by 4, the number of days that the substance was decaying, we find that there are 3 half-lives in those 12 days. So that's our h. We'll plug h and the amount of mass remaining into this half-life formula. Plug those values in and we get this. 5 for the amount of mass remaining equal to the initial mass times half to the third power for h. First, we'll simplify. So we want to solve for initial mass here to find what the initial mass was of the sample before it started to decay. So first, we'll simplify this exponent expression here. We can change a half to 0.5 and then find 0.5 to the third power using Desmos. So 0.5 and power 3 equals 0.125. So now we have 5 equals the initial mass times 0.125. We want to get initial mass by itself. We're solving this equation for initial mass. So we do the opposite to get rid of this 0.125. Since we're multiplying by 0.125, we're going to divide by 0.125 to get initial mass by itself. So we divide both sides by 0.125. We'll have 5 divided by 0.125 equal to this thing divided by 0.125. The 0.125s will cancel out and we'll be left with initial mass on this right-hand side. So 5 divided by 0.125 is 40. Simplifies to 40. So the initial mass would equal 40 milligrams. So that's the answer to the first question, and we can see here by clicking on the key that that's the correct number. So basically, we plugged in the known information into this half-life formula, and then we solved for initial mass by solving the equation, treating it like the unknown. So now we want to find how much of the mass would be remaining after 5 weeks. Instead of 12 days, what if it decays for 5 weeks? So that's a lot more days. Since we're given the half-life in days, we need to convert the 5 weeks to days. So 5 weeks, if we just multiply, there's 7 days each week. So if we multiply 5 times 7, we'll find that there's 35 days in 5 weeks. So then we can find the half-life by dividing 35 by 4. You can find all the half-lives. So there's 8.75 half-lives in 35 days. We'll use this as our h. We'll use 40 as our initial mass in our half-life formula. So we have 40 for initial mass, 8.75 is our h. And then we just want to simplify and find how much mass will be remaining then after 5 weeks. So we can plug this expression into Desmos. So we'll do that. So we had 40 times a half in parentheses or you can use 0.5, whatever is easier for you. We have this exponent, 8.75. So the remaining amount of mass would be 0.0929 milligrams. So here we have this expression simplifies to 0.092 milligrams as what's remaining in the mass. So that's equivalent to this if we round it to 4 decimal places.